So we've done this type of problem before, but we're using a different equation now that we're talking about circuits. Notice that the problem talks about a battery, a resistor, and an ammeter. And so the equation that we should be thinking about is Ohm's law, V equals I times R. But since the question asks about the current, we're going to rearrange this so that the I is by itself. Again, I'm choosing that based on what the question is asking me to find. I've also rewritten this using the proportionality constant instead of the equal sign. Okay, the proportionality sign just asks me to focus on what changes in the problem, and both the V and the R will be changing. So I'll enter the 1/2 for the V, and I'll enter a 5 for the R. And then I'll do a little bit of math. 1/2 divided by 5 would be 1/10. And in the past, this is where we stopped. But now, because I know what the initial circuit reading is, and I'm asked for an actual value of current, I'm going to take this 1/10 and multiply it by the original amount to find my new value of current, 0.72 amps. All right, this question also deals with a circuit. Again, V and I and R are the key variables, so we're again going to use Ohm's law. But in this case, the question just asks about voltage. And so my formula is really ready as it goes, as it's written. I'm just going to change to thinking about changes rather than plugging in values of current and resistance. So in this case, again, both factors are being changed, both I and R. And so I'm going to include them both here. I is changed by a factor of 1/3. R is changed by a factor of 4. Notice it's not a fraction in this case because the relationship is a multiplication, I times R. And we'll do a little math here. This just comes out to be 4/3. And again, this is where we stopped in the past, but we're going to take it one more step. And because the original value of voltage is 24 volts, and this is the new value, it's proportional to 4/3, we will take 4/3 of 24. Again, grab a calculator and figure that out. It'll come out to be 32 volts. So the new voltage, 32, is 4/3 of the old voltage, 24. All right, and one more equation that we used within this unit. This is related to Coulomb's law, okay, where we have different values of charge, and a distance between those two values. Again, in this case, look to see what the problem is asking us about. It's asking us to find a force. And so this formula is fine the way it is. I don't need to do any rearranging, but I can notice in reading through it that only Q1 is changed and D is changed. And so the KE and the Q2 are not really part of this situation. I just need to look for changes in Q1 and D. So I'm going to simplify my proportionality that way. I'm going to put my 1/3 factor on the top of this fraction, and the 2, because D is doubled, that's a factor of 2 on the bottom. But notice that's not just a 2, it's a 2 squared, because D is being squared in the formula. All right, might want to take an in-between step to change that 2 squared to a 4. And then 1/3 divided by 4 would be 1/12. And again, we'll take this 1/12 and we'll multiply it by the original value of force to find the new value of force, which is going to be much smaller, only 1/12 of the original value. It comes out to be 30 newtons.